are going to finish up our, what we started the other day, yesterday, I forget what day it was. Last time we were together, we were working on page 26. And we are going to start, everybody got your notes out? Page 26? Here we go. We're going to start with a few. I'm going to go a little bit out of order. So we did the first 17 last time. So I'm going to do 20 and 21 and 26 and 28. Then we're going to come back and get the rest of them in a second. But these are all like the ones we did the other day. There's some different ones mixed in, but these are exactly like the first 17. Well, I'm not quite honest about that. There's a little bit of difference. There's a number out in front of some of these, but we didn't have that the other day. Do you remember that?
Yep.
So I'm going to cover that number up for a second, and I'm going to pretend that this is the problem. Now, this is exactly what we did the other day. Do you remember trying to make these two numbers match?
Yep.
Okay, they don't match. However, 9 can be turned into a 3 because 9 is 3 squared. So we'll write it as 3 squared. 9 is 3 squared. And then as soon as these two match, remember that was the answer?
Yep.
So the answer to this part of the problem right here is 2. But in the beginning, we were timesing that by 2. That 2 is timesing that. So the answer to the problem is actually 4.
Oh, that's great.
All right, let's come over here. Same thing. Deal with this. What's the log base 2 of 8? Well, I don't know. 2 and 8 don't match. But what do I know about 8? It's 2 to the third.
Yeah.
So this is the log base 2 of 2 to the third. Because if I'm asking you to do this without a calculator, you're always going to be able to change it, okay? So figure out what you can change it into. 8 is 2 to the third. So what's the answer to this?
9.
Well, the answer to this part is 3, but that is getting times by 3, so the answer is 9. You're exactly right. Final answer is 9. All right, here we go. Cover up the 4. Oh, that's an easy one. What's the log base 2 of 2 to the first? 1. This is just 1, isn't it? But the 1 is getting times by 4, so the answer to the problem is 4. This one doesn't have a number out in front, so I don't need to worry about it, but it's a little bit trickier because in order to do this, you have to change this 1 into 8 to the power. 8 to what power is 1?
0.
0. So the answer to that problem is 0. We had one like that yesterday. 8 to the 0 power is 1. So the log base 8 of 1 is 0. Okay, here we go. Now we gotta look at these other ones that look absolutely terrifying. I told them last year, we used to have something called the Marion County Math Contest where all the schools in Marion County would compete against each other mathematically. And every time I had the opportunity to write a test for the contest, I would sneak one of these on because they looked so hard, but you're not gonna believe how easy it is. Whenever, just like here, Remember when these two numbers matched, the answer was that?
Yeah.
When these two numbers match,
Oh, the answer's 10.
the answer's 10.
Oh, that's awesome.
That's it.
That's so cool.
There's no work to do.
That's cool.
There's nothing really, I mean, there is math behind it, but as long as you can remember it's just gonna be 10, that's it. There's nothing else for you to do. So, what do you think the answer to 19 is going to be?
2.
2? Because the 8's match, so it's 2. What about 22?
Oh, it's gonna be 4.
It's gonna be 4, and that one, you need to remember that ln is log base e, right? ln is an abbreviation or a symbol for log base e. So we got both e's, so the answer is 4. Right? How about 23? 11, 24, 7, 25. Remember, the base on LOG is 10.
7.
So that one's just gonna be 7. And 27 is 6. Because ln is log base e. Wow, those are so simple. Right, we're gonna remember that property, right? So on test day, when you have 17, from the log base 17 of the square root of 11, you're gonna say the answer is square root of 11. That's exactly right, it's whatever is up there. All right, we're gonna type into our calculators now. And yes, it is that easy, we are typing into our calculator. All right, so here we go. Problem A. Log, find your log button, 8.61. I'm not sure what we're all talking about. As long as it's math, I don't care. What did you get for A? Now remember, the direction said round off to the nearest 10,000. How many decimal places is 10,000? 4. So 0.9350.
Yep. Oh, yeah.
B, ln, now you have an ln button, it's right under your log button. So ln 12, 2.4849. Huh? Who's talking about this? Are we all good? All right, what about C?
How do you do negative? Mine says
It's error.
syntax.
So nothing.
You can't do negatives. You can't take the logarithm of a negative. And I'm never gonna ask you to explain this, but I want you to think about it for a minute. Back when we studied our BFFs, this was y equals ln x. This was what you memorized as your BFF. ln x, okay? Notice in the picture, where are all of the x's in the picture? Aren't they all positive? You don't have any x's back here. There's an asymptote here. So x can never be negative. You cannot input a negative number when you're logging. Okay? All right. So that one's no answer. All right, what about D? Log 15.47. What'd you get for D? 1.1895.
5.
Remember, when we say 4 decimal places, we mean after the decimal point. ln 1 divided by 23. Did you get negative 3.1355?
Yep.
Now, the rule is you can't input a negative. Negatives can come out. Negatives can come out. You got them down here, all over the place. But negatives can't go in. All right. So what's the answer to F? No answer. And G? No answer. And H? 3.296. 3.2960, is that what you said? You know, that 1977 didn't just crop up randomly, that's the year I graduated from high school.
Hey.
Can you believe that, 1977? 1977! All right, here we go. Part 3, solving. This is probably the most important thing we've done this week. If we can get this figured out, it's real easy, but we just have to remember it. We are gonna be all set. This is huge. So, no. When we are solving a logarithmic equation, that's what this is. This is an equation with a logarithm in it. When we're solving it, we need to get rid of the logarithm. You can't divide it, or you can't do anything like that. Here's how you get rid of it. First of all, everybody knows the base here is 10. Okay? So we're gonna do, some teachers call this log rolling, some teachers call it loop-de-loo. I don't care what you call it, you just need to know, you start right here with the base, raise it to this power, and it equals this. So 10 to the third equals x. 10, start with the base, to the third equals x. Do that with your hands so you remember 10 to the third equals x. So what's the answer? What's 10 to the third?
1,000.
1,000. So the answer to this is 1,000. 1,000. This is exactly the same situation. Jacob?
I don't see a 10 after the log. Do we have to put that there? Or-
That's the base.
LOG means common log, there's always a 10.
Okay.
If it's LOG with no other number, now, there could be a 7 or a 12 there, but it would have to be written there.
Okay.
If there's no number written, it's automatically a 10. Those are called common logarithms. Okay, we need to know that too, that the base on LOG is always 10. So, the base here is 10. So now, here we go. We're gonna get rid of that log, so we're gonna say 10 to the negative first equals x. What does 10 to the negative first mean?
1 over 10.
1 over 10. You guys are awesome.
Yep.
So the answer is 1/10.
Oh, this is awesome.
It is.
This is
It is.
This is like.
All right, here's another one.
Oh, yeah.
Here we go. 10 to the negative second equals x.
1 over 100.
1 over 10 squared, which is 1 over 100. So the answer is x equals 1 over 100. You are solving an equation, so your answer is going to be x equals.
Yeah, cool. Oh, I don't know, X is just like,
Okay, so first thing we got to do is remember, what does ln stand for?
Log base.
Log base e. Solving it is exactly the same. So we start with our base, raise it to the fourth, equals x. Now, 10 to the third, I could physically multiply 10 times 10 times 10. E to the fourth, without a calculator, I don't know, that's a number like pi. It just is. So we're just gonna leave it e to the fourth. We're not using a calculator on these, so we're just gonna leave it e to the fourth. Perfectly okay. It's like saying 22 pi, it's okay. All right, ln x equals 6.
Even 6.
Same thing, we'll start by log base e of x equals 6. ln is log base c. It's like an abbreviation. So then, start with the base always. So e to the 6 equals x. Done. Done. Finished. Now, be careful on this one. I know what you might be thinking about, something we did earlier. This is an equation, you guys. There's an equals in this. So if you don't like this 3 out here in front, you're allowed to divide it. You're allowed to divide it out, because aren't you allowed to divide both sides by something in an equation? The things we had earlier were not equations. This is. So we're just gonna divide both sides by 3, and now our problem looks like this. What's the base here? I need a base. What's my base? 10. So 10 to the first equals x. Everybody got it? So what's 10 to the first? Just 10. So x equals 10. All right, so taking a clue. Well, first of all, what does ln mean? Log base c. So I'm going to take care of that because I need a base to do this problem. I need to see a base. So now I do. But how about this -2? What might I do with that? Divide, get rid of it. So I'll divide. Now when I divide, all it does is cancel out. That part stays the same. So it's log base c of x equals -2. So then I can start with the base. E to the -2 equals x. We do not like negative exponents. So what do we do with a negative exponent?
1 over e squared.
1 over. So your answer is going to be 1 over e squared. Scott Anderson, where's your lanyard? Oh. Oh. Booker, why do you have a coat on? Why do you have a coat on? Huh? Who said that? Coach you? So I'm gonna check with him. And then if you're not being honest, you're gonna have a whole bunch of people mad at you, not just me. All right. Who else is not in uniform? Good. Okay. Now, what's next? Where am I? I'm on number H. Ready for H? All right, so what am I gonna do with letter H? Well, we're back to a log. So I'm gonna slip a 10 in there. And then I'm gonna rewrite it. And what's it gonna say when I rewrite it? 10, well, this one's gonna say 10 to the 1/2 equals x. This one will say 10 to the 1/3 equals x. They're almost the same problem. What does this mean?
You set it up in radical.
It's a radical. And under the radical would be a 10. And this one would be a square root. So isn't the answer just the square root of 10? For this one? Well, what happens over here? Same thing, only isn't this one gonna be a cube root? Because the exponent was 1/3? Now, I don't know what the square root of 10 is. I could figure it out on my calculator, but without a calculator, this is the end. If that had been a 25, I would say 5. But since that's, I don't know, I'm just going to leave it. Last one in this section. ln x equals 1/4. So what does ln stand for? Log AC. So then I'll loop-de-loo it or log roll it, whatever you call it. E to the 1/4 equals x. Wait a minute. The 1/2 was a square root. The 1/3 was a cube root. What's the 1/4? The 4th root of e. There it is. E to the 1/4. 4th root of. We're watching the clock, you're not down, we have lots to learn. Alright, so that is really, really important. That little trick there where you take e to the 1/4 equals x, that's huge. Right along with that, oh, by the way, that's 3.3, so that homework will be due on Monday, okay? 3.3 homework will be due on Monday. Right along with that rule, though, are 3 more rules. They're called properties of logarithms. I really didn't leave you room, but maybe up there where the calculator part was, maybe you have a little room there that you can write these down. So, the log of m times n is the log of m plus the log of n. These are properties. They are hard and fast rules. There is no distributive in logarithms. If you have the log of 2 things being multiplied, when you separate it, it becomes an addition. If you have the log of 2 things being divided, when you separate them, it becomes a subtraction. Again, these aren't things that we're going to discuss or argue about. These are the rules. And then the last rule says that if you have a number out in front of a logarithm, you can pull that number off and make it an exponent. So if you have a coefficient, a multiplication thing out here, you can pull it off and make it an exponent. These are our rules. We're going to practice some problems with them now. So the first problem in 3.4 number 1 says, put this together as a single logarithm. So instead of having 2 logarithms, put them together and have 1. Now, I want you to look at your rules. What does this kind of look like? The middle one doesn't look like this right here? And what does that equal? That equals the log of m divided by n. So what is ours going to equal? X divided by y. Perfect. That's it. You've written it as 1 logarithm. It is cool. I am happy to hear you say that, Eli. Cody just said, Miss Coach Johnson just asked me this morning, don't you ever get bored? No way. No way. Get bored with math? All right. Get bored with bench press? Yes, I hate it. But not now. All right, so here we go. Look carefully. See that right there? We got to deal with that. Before we do anything, we have to deal with that. So, look at your rules. This is not a rule. look at your rules. Do you see anything that's got something out in front?
Yeah.
Yes, right here, right? And what do we do with that something out in front? He shows up as an exponent. So I'm gonna start by writing this as log x squared. This comes off and becomes an exponent. The rule says that. Now I need to put these together into one logarithm. So look here, that's a plus. So that goes with the top one, doesn't it? So since I'm adding, what do I end up doing to my two numbers? Or my two letters here? Multiply, is this gonna be x squared y? One third log z plus log w. Well, this is kind of the same as what we just did. What do you think we'll do first? No thoughts about what to do first? What do we do first over here?
Do 1/3.
So we gotta take care of that 1/3. Where does he go?
Exponent.
He becomes an exponent on z. So log z to the 1/3 plus log w. Z to the 1/3, what's that? What's z to the 1/3?
Where is it over there?
The cube root of z. So we have the log, thank you, of the cube root of z plus the log of w. Now your job is to put those together into one logarithm. Log what? Cube root of z times w, that's exactly right. Why am I putting it together as a multiply? Because the original was an add, and when the original is an add, when they go together, it's a multiply. Alright, let's do D, and then I'll see how you can do with the next one here. But let's do D together, because there's a little bit of craziness happening in it. Alright, what do you want to do first? So we gotta make the 4 an exponent, and it's gonna go on the whole thing, it's gonna come right here. Oh, how about the 3? We'll make it an exponent also. So I'll leave the minus and just pull the 3 off. Okay? Now what do you think? Put it together as a division. It is a subtraction, so this will be the log of, okay, on top, I have xy to the 4th, and on the bottom, I have x cubed. That goes first over second. Do you notice anything about that?
It wouldn't matter.
Access.
This can simplify, can it? So this is gonna be the log of x4, y4 over x3. And these are gonna do some canceling, so we're gonna have left just the log of xy to the 4th. Now, Eli, were you asking a question about something?
Yeah, I was, yeah, but you.
I answered it. Everybody okay? Now, the next couple problems, or I guess E through H, are exactly the same idea, but they aren't letters now, they're numbers. Well, I think that makes it even easier. what are we gonna do with log 4 plus log 7? We're gonna multiply them, and so what is our answer going to be?
Log 28.
Log 28. Why am I multiplying them? Because my rule tells me to, right? Now notice, it isn't 28, it's log 28. When you combine two logarithms, you get another logarithm, just one. So it's log 28. What's F? If you said log 2, you're right, because this is the log of 16 over 8. And 16 divided by 8 is 2. Any ideas about G? Please, please don't panic. Any thoughts about G?
Would you just do it like it's log?
Absolutely, because Eli, ln is a logarithm. It's a base E. And all logarithms, no matter what their bases are, operate the same way. So these rules, I mean, I just wrote log because I'm lazy. This could be any base, right? It wouldn't matter. Any base that works. So the ln rules are the same as the log rules because they're all the same thing. So this is just going to be ln 19 over 8. Now, I don't know what that is. 19 over 8 is fine. Right? All right. Try H on your own. See if you can tackle it. See if you can make any progress with that one. Melissa, what'd you do first? Move the exponents. I hope everybody did that, because that's what you want to do first. So, we're going to move the exponents. So we have ln 2 cubed plus ln 36 to the 1/2. Perfect. What's 2 cubed?
8.
So this is ln 8. What's 36 to the 1/2? 6. Why is it 6? Because 1/2 means square root. So this is the square root of 36, which is 6. Right?
Yeah.
Now, that's an add. You gotta put them together. We're gonna make it ln
48.
48. We're gonna stop there, do a couple of quick review problems on the board. Very good work. Very good. Okay, so here's what I'm gonna do. I've got 6 review problems I'm gonna put on the board. I'd like you to copy them down on a piece of paper. And then I need different people to come to the board and put their answers up when they get them figured out, okay? So this will be a little bit of review of everything we've done in the chapter so far. So we'll see how we do with that. Okay, we're all writing these down.
Yeah, I did that shit too.
We get one on there, just a lot of put it out there.
Yep. But you only get to put one up. Okay, you guys back here in the chatty corner, are you doing these?
Yeah.
Okay, this is review. We should all be able to do all of these. We only have one left. So I need somebody who hasn't been up already to put that one up there. All right, let's look at them and make sure we all got the right answers. I think we're correct all on the board. Did you all recognize for this first one that 16 is 4 squared?
Yep.
So as soon as you got those to match, you know your answer is 2. This is what we just talked about today. 5, we start with the base. 5 to the second equals x, 25, perfect. This was on your quiz, this kind of problem. You flipped it and squared it, 25 ninths. This will be,
That's 3.
it should be 3 cubed.
Oh,
Yeah.
I did it wrong.
No, it's okay, I think you were just getting ahead of yourself. 27 is 3 cubed, so the answer is 3. Would everybody agree with that? And then here, ln means log base e, so e to the 5th, 5, perfect. And this is kind of a long one. First thing we did was pull the exponents off. So 3 squared is 9, 2 cubed is 8. Then we multiplied those together. That is absolutely correct. Got it? So that's kind of a recap of everything we've done so far, except the calculator work. Okay? All right, we've got a few minutes. You got a bunch going on. Canned food drive tomorrow, last day. Papers due tomorrow. You got homework due all over the place. So.